Good day, students. On this clip, we're going to be going over 4 examples on how to solve logarithmic equations. But before we start, I just want to talk a little bit about the domain of logarithmic functions. We have to recall that the domain of log functions, logarithmic functions, is basically x has to be greater than 0. Okay, so it can only log functions can only take inputs that are greater than 0. So in essence, log base b of a has a defined output only if a is strictly greater than 0. Okay, so if if a is less than or equal to 0, then log base b of a is undefined. All right, so let's use some concrete examples. So let's say we have log base 2 of 3. This is defined because 3 is greater than 0. Okay, but if we had log base 4 of 0, this one is undefined. It's undefined because our input is equal to 0. Okay, remember it has to be, our input has to be greater than 0. Okay, so this is undefined because 0 equals 0. Alright? Or if we had log base 5 of -2, this is undefined also. It's undefined because -2 is less than or equal to 0. Okay, so let's keep that in mind, that the argument for the logarithm has to be greater than 0. If you have a 0 or a negative argument, then that term is undefined. Alright, so with that in mind, let's write down the instruction for the notes and watch out for these while we're solving the problems, okay? So, instructions as follows. Solve the following logarithmic equations and do a check, okay? Doing a check is critical here because we want to make sure that we exclude inputs that are not in the domain. Alright, for question number 1, we're going to be solving the equation log base 7 of 3 plus log base 7 of x equals log base 7 of 12 over 5. Okay? Alright, for this one, the first thing we're going to do, we have to condense the two logarithms on the left side into one before we eliminate, okay? So to condense these, we're going to use the product property of logarithms to rewrite this as log base 7. So the product property says if you multiply the quotient, the arguments of the logarithm is the same thing as adding the independent logs. So using the reverse of the product property of logarithms, this is going to be log base 7 of 3x. Okay? Log base 7 of 3x equals log base 7 of 12 over 5. Now that we have identical logarithm and the base, we're going to go ahead and eliminate the logarithms using its inverse, which is exponent. So since the bases are 7, I'm going to exponentiate both sides using 7 as the base. So I'll have a big 7 on the left, a big 7 on the right, and then a little log base 7 of 3x. And then on this side, I have a little log base 7 of 12 over 5. Okay? Now, since these are inverse operations that you cancel each other out, these are the inverse property of logarithms. Same story here. So on the left side, we're going to have 3x equals 12 over 5. Okay? So isolate x, I'll divide both sides by 3, but I'll run into some complications here. So a more elegant approach would be to multiply by the reciprocal of 3, which is 1/3. So multiply both sides by 1/3. On the left side, we're going to have x, just to divide out. 3 goes here 1, 3 goes here 1, and then 3 goes here 1, 3 goes here 4, and then x equals 4 over 5. So there goes your answer. Alright? Okay, now let's go ahead and do a check. Off the top of our heads, we can know that this doesn't look like a problem since it's positive, but let's do a check anyway, just to verify. So I'm going to put my check on the right side here. So let's call this check. I'm going to check x equals 4 over 5. Alright, so let's do it. So we're going to have log base 7 of 3 plus log base 7 of our solution 4 over 5. Is it equal to log base 7 of 12 over 5? These are the product property of logarithms. This becomes log base 7 of 3 times 4 over 5. Is it equal to log base 7 of 12 over 5? Okay? And then we'll just multiply the two fractions on the left side. We can express 3 as a fraction, 3 over 1. So we're going to have log base 7. But 3 times 4 is 12 over 5. Is log base 7 of 12 over 5 equals log base 7 of 12 over 5? We have identical terms on both sides, so our answer checks out. Alright, okay, let's move on to question number 2. So for question 2, we're going to solve the equation log base 5 of 8 equals 3 times log base 5 of x. Okay. Now we notice that this logarithm base 5 is by itself, but this has a 3 in front, so we're going to use the power property of logarithm to power this up. Okay, this coefficient becomes the power of the x, so we have identical log and bases, so we have log base 5 of 8 equals log base 5 of x to the third. Okay. Now we have log base 5 and log base 5. We can now eliminate the logs from both sides. So since the bases are 5, the basis of exponentiation will be 5. Okay, so put a big 5 on the left, a big 5 on the right, and then a little log base 5 of 8 equals a little log base 5 of x to the third. Alright, so on the left side, the 5 and the log base 5 cancels out. So we're going to have 8 equals on the right side, a 5 and a log base 5 cancel out, x to the third. Okay, now to finish this up, we need to just get rid of the third power of the x. So what we can do is we can take the cube root of both sides. So we take the cube root of x to the third and the cube root of 8. Okay, using the reflexive property of equality, I can switch this around. I'll have x equals the cube root of 8 is 2, right? Because we know 2 to the third is 8, hence 2 equals the cube root of 8. Okay? Alright, so our answer is x equals 2. Now, to finish this off and be confident that our answer is correct, we're going to do a check on the right side just by inputting our solution into the original problem and see if we generate a true statement. Okay, so the question is log base 5 of 8 equals 3 log base 5 of 2. So we're testing x equals 2. Okay. Now I can just power this up to make my logarithms identical. So I'll have log base 5 of 8. Is it equal to log base 5 of 2 to the third? So log base 5 of 8. Is it equal to log base 5, 2 to the third is 8? Is it? Yes. The same terms on both sides, so our answer is correct. Alright, let's move on to question number 3. We're going to solve the equation log base 4 of 3x minus log base 4 of x plus 3 equals 3 over 2. Okay? Now we need to condense these two logarithms into one before we can eliminate. So we're going to use the quotient property of logarithms to condense these two. We're going to be dividing the arguments of the logarithmic values, okay? of logarithmic terms. So to do that, we're just going to bring down the log. We're going to bring down the log base 4. So we have log base 4. The first argument is a numerator. Second argument is a denominator, right? X plus 3 equals 3 over 2. Now that we have condensed, we are now going to eliminate. Remember, you condense first before you eliminate. We just have one log in this on the left side, so we don't need to create uniformity, okay? So to eliminate, the base is 4, so that's our basis of exponentiation. So we're going to put a big 4 on the left side and the big 4 on the right. And on the left, I'm going to have a little log base 4 of 3x over x plus 3. And on the right side, a little 3 over 2. Okay? Alright, on the left side, the 4 and the log base 4 are inverses, so they cancel each other out. So we're going to have 3x over x plus 3 equals, now using the rational exponent property of logarithms, this 4 to the 3 house can be rewritten as the square root of 4 raised to the 3rd power. Okay? Alright, let's simplify this radical on the right a little bit further. So we have 3x over x plus 3. The square root of 4 is 2. And then we have 2 to the 3rd. So finally, we're going to have 3x over x plus 3 equals 8. Now to get x by itself, we'll multiply both sides by x plus 3 on the right, and x plus 3 on the left. Okay? So we're going to distribute this 8 to both terms. And on the right side, these two are identical, so they divide out. X plus 3 goes here 1, x plus 3 goes here 1. So now we're going to have 3x equals 8x plus 24. Okay? Alright, now next I'll subtract 8x from both sides. Subtract 8x, subtract 8x. So we'll have negative 5x equals 24. Divide both sides by negative 5. And we'll have x equals negative 24 over 5. Okay? So now that we have a negative solution, we have to be really careful to check to make sure that this answer is correct. I can't box it yet. To make sure that this answer is correct. So let's do a test. We're going to test x equals negative 24 over 5. On the right side here. So let's do a test. So we're going to test x equals negative 24 over 5. So if we do that, we're going to have, plugging it into the original question. Question is log base 7 of 3 times negative 24 over 5 minus log base 7 of negative 24 over 5 plus 3, is it equal 3 over 2? Just looking at this terminology right here, what we'll do is we're going to multiply these two, right? Multiply these two together. So we're going to have log base 7 of negative 72 over 5. Okay? Minus log base 7 of, if I write negative 24, we can just leave it alone as negative 24 over 5. And then write this as a fraction of 5 with a denominator of 5, so put it over 1, and then we'll have 15 over 5. Okay, is it equal to 3 over 2? Now if you look here, this is a negative logarithmic argument already, so this term right here is undefined. Because remember, you cannot have a negative logarithmic argument. If you do, that means this expression is undefined. So in this case, we have no solution, since our input is undefined. We have no solution to this equation. Alright, let's move on to the last question. Question number 4. We're going to solve the equation log base 2 of x plus 1 plus log base 2 of x minus 1 equals log base 2 of 3. Okay? So now we have to condense this logs obviously before we eliminate. So to condense, we're going to use the product property of logarithms. So we have log base 2, and we're going to multiply the respective logarithmic arguments on the left side. Okay, so we're going to multiply those two. So we're going to have x plus 1 times x minus 1 equals log base 2 of 3. Okay, now we're going to distribute this to both first, outer, inner, and then last. So that's going to give me log base 2 of x squared minus x plus x minus 1 equals log base 2 of 3. Alright? So simplifying this, I'll have log base 2 of x squared minus 1 equals log base 2 of 3. Now that I have consolidated my logarithms and I have uniform log base 2 on both sides, I can now go ahead to eliminate. Okay, since the bases are 2, I'm going to use that as my basis of exponentiation. So put a big 2 on the right and a big 2 on the left. On the left side, we have a little log base 2 of x squared minus 1 equals on the right side a little log base 2 of 3. Okay? Now, since these are inverses, they neutralize each other out. So you're left with x squared minus 1. On the right side, these will neutralize each other out, equals 3. So what I'll do next is I'll add 1 to both sides. And then I'll have x squared equals 4. And to isolate x, I'll take the square root of both sides, because that's the inverse of square. So I have this absolute value of x equals 2. Absolute value can be written as plus or minus x equals 2. And I'll divide both sides by plus or minus 1 to get rid of this plus or minus on the left side. So we're going to have x equals plus or minus 2. So the solutions are x equals 2 and x equals negative 2. Okay? So we're going to have to do 2 checks here to make sure that to see which one is. If both of them are the answer, none of them or one of them is the answer. Okay? So let's do the first test. So we're going to, so this is a test. First one, let's test the one that looks suspicious, which is x equals negative 2, to see if we generate any negative arguments for a logarithm. Okay? So we're going to have log base, in the original problem, log base 2 of negative 2 plus 1 plus log base 2 of negative 2 minus 1. Is it equal to log base 2 of 3? Okay? If I simplify this, I have log base 2 of negative 1 plus log base 2 of negative 3. Is it equal to log base 2 of 3? Now look at these. You have a negative argument for a logarithm here and here. These two terms are undefined. So since these two terms are undefined, so they are undefined. So you notice that so this is negative. This term and now term right here is undefined, and this term also is undefined. So what does that tell me? Well, it tells me that the first answer, negative 2, is not a solution. Okay, because it generates input values that are not in the domain. All right, now let's test the next value, x equals 2. So the question is log base 2 of 2 plus 1 plus log base 2 of 2 minus 1, 2 minus 1, is it equal to log base 2 of 3? Is it? So in this case, we have log base 2 of 3 plus log base 2 of 1. Is it equal to log base 2 of 3? We don't have any negative arguments for the logarithm, so that looks good. Using the product property, we're just going to multiply these two arguments. We have log base 2 of 3. Is it equal to log base 2 of 3? Absolutely is, so our answer checks out. That means the only solution we have for this problem is x equals 2. Okay, so you see how important it is for you to do a check when solving logarithmic equations. thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. More videos can be found on mathreserve.com. Thanks again and have a wonderful day.